Good day, madam. My name is Dilanta Herath. My index number is 258776U. So in this video, I will demonstrate movie recommendation system implemented using Apache Spark and Google Colab. I have implemented recommendation strategies like collaborative filtering and content-based filtering, association rule mining, and finally hybrid recommendation pipeline that combines these approaches. So here I'm using a movie data set from Kaggle, especially leveraging the small rating file movie data and metadata and the keyword association. And this is the data set. This one is having more than 2 million records. So first, I need to set up my environment. Install this OpenJDK 11 PySpark, and it's already environment ready. Then creating this Spark session. Here, especially need to configure this 8 GB RAM. Otherwise, it will give some error while running this application at the bottom. Then I uploaded those CSV file into my sample data, keyword CSV, movie metadata, and rating, and verify those things also. Then in the data loading and initial inspection, I enabled header reading and schema inference. Looking at the initial counts, I have over 100,000 rating, over 45,000 movie records, and more than 46,000 keyword entries. Those are the things. Then I quickly inspect the first 5 rows of each data frame to understand the structural layout. Notice that genre columns, the metadata table, and the keywords column are stored as a string 5 JSON array, which I will need to pass later. Then I will talk about data cleaning and pre-processing. For the rating table, I explicitly cast the columns to their proper data types, drop any rows containing null values, and strictly filter for valid rating ranges between 0.5 and 50. And regarding the movie data cleaning part, mm, I write a user-defined function using regular expression to extract the actual genre names out of the raw JSON string. Also extracted the release year and remove duplicate movie IDs. Narrow down columns to only what I need. These are the data. Then also process that keywords. It's similar to the previous one. So finally, I join the clean movie tables with past keywords, performed an inner join with the distinct movie IDs present in our ratings dataset to ensure I am only keeping movies that have actually been reviewed. I then cache both data frames in memory to boost the performance of subsequent operations. Regarding the exploratory data analysis, I checked out movie popularity. The most heavily rated movie here is Terminator 3 Rise of Machine with 324 ratings. and the user activity also. Yeah, the average user provides roughly 149 ratings. The minimum activity is looked at 20 ratings. Then let's look at the strategy, collaborative filtering. Uh, I used Spark machine learning's alternating least square algorithm to decompose our use item rating tricks into lower dimensional latent factor matrices. This is my model train. Evaluating the model prediction against the test, it yield a root mean squared error approximately 0.91, then mean absolute error 0.71. So general things. With the model trained, I call recommend for all users to generate the top 10 recommended movie arrays along with their predicted discourse for every single user in the dataset, and got this dataset only showing 5 users. Then here I isolated specific user for testing, whom I will refer to as the target user. Therefore, user 1, the model recommends title like Urban Explorer, and the return of the king based entirely on collective user behaviors. Then here I check the user history. I can review user one's actual history. I see they have highly rated titles like American Pie, indicating they enjoy comedies and lighter dramas. Second approach is content-based filtering. I constructed a unified text string for each movie by merging its genre names and keywords, replacing spaces with underscores to perform unique tokens. Then also build a speech extraction pipeline consisting of tokenizer and a hashing TF transformer, set of 500 features, and IDF estimator. Lastly, an L2 normalizer is applied so that I can compute cosine similarities directly via dot products. Then executing this engine for user one extract the movies they rated 4.0 above and feeds them into the system. The content-based pipeline suggested the 12 angry men and a man and woman and a bank as the top matches based purely on the description and metadata similarity. Okay, let's come to association rule based recommendation. The third model leverage this association rule mining. I treat each user's collection of highly rated movies as a transaction bucket. This maps out our data perfectly for discovering co-occurrences patterns across all 668 active transactions baskets. And then I trained Spark ML FP growth model specifying minimum support threshold of 3%. And confidence 30%. Then isolates nearly 346,198 records. Then there's the rule extraction. From those item sets, model established over 1.5 million association rules. These rules dictate strong conditional relationships, completed confidence matrices, and lift scores. By mapping the row IDs back to actual titles and sorting by lift, I get highly transparent rules. For instance, notice how frequently certain movie configuration strongly imply that user will also like the movie Cold Mountain. Then I implemented a function that checks our target users' watch history against these rules. Say for user one, the matching rule successfully recommend titles such as Sleepless in Seattle with defined confidence matrix. And the final strategy is a hybrid recommendation system. So I took all candidate movies that the target user hasn't seen yet and generate their raw collaborative scores because the scoring scales of ALS and content-based filtering differ. I scale the ALS predictions linearly between 0 and 1. I then broadcasted content-based similarity scores across the Spark cluster, normalized them to 0 to 1 range as well, and append them as a new column to my candidate matrix. Then I established a hybrid score using weighted sum, assigning 60% weight to the collaborative filtering signal and then 40% to the content-based score. Then sorted the combined matrix yield a balanced and personalized recommendation list topped by Kafka and 12 angry men. Yeah, see, these are the result. So regarding the evaluation metrics, I validated the collaborative pipeline, then calculated average pressure at K, setting K to 10. This cross-checks the top 10 cluster recommendation against what user actually rated highly in the held out test data set. Then this is the summary. So based on the summary, running this diverse pipeline on PySpark, I successfully mitigated individual system drawbacks like the cold start problem or limited serendipity through a robust hybrid approach using PySpark that ensured this entire workflow can scale horizontally to handle massive production level data set seamlessly. So thank you for watching this. Yeah, thank you, madam. That's all from my end.